All right, here's that second video I was talking about. This is an additional resource. If you would have been in class, I would have had you practice this just to make sure you really understood it before I had you do any kind of book work or any homework or anything like that. So notice I also gave a little extra reference on it. I have, this is example 5 on page 461. So you'll want, if you need to like look at any extra explanation, it's in the book for you that way. So we need to do the opposite of exponents, and so our inverse of exponents is logs. So I'm just going to take the log of both sides. So log that side and log that side. Let's write that out a little nicer. I'm going to zoom in. So we would have log of 5 to the x plus 1 equals log of 6 to the 2x. And something, I don't remember if I pointed it out really well in the first video, but something to notice is that this is log base 10 on both sides. And because it's not log base 5 or log base 6, it doesn't undo like we've done in the past. And we can't do that because we have two different bases. So we're just going to take the generic log base 10. And I might point out how this is different than something else, so I'll show you in a second. All right, so these exponents can come out front because of the power property. So this is x plus 1 times log 5, and this is just 2x times log 6. So on this, we need to distribute the log 5 to both terms. So we get x log 5 plus just log 5 equals 2x log 6. And now I want to get everything that has an x in it on the same side. So I'm just going to subtract minus x log 5 from both sides. Let me zoom out a little bit so you guys can see better. And just remember log 5, that's just a number. So I just leave that. I'm not going to do anything with it. But here's what I have on the right side of my equal sign. And now I'm going to look for that greatest common factor. And the only thing these two terms have in common is the x. So if I factor out the x, I'm left with 2 log 6 minus log 5. And now I've done what I wanted to do. I've got my x in one place. So I'm going to divide both sides by 2 log 6 minus log 5. It's a lot of writing. I know you guys are probably already saying, it's so much work, Mrs. Ice. I don't want to do it. But don't worry, we're almost done with logs. We're going to be heading into trig before you know it. So now my final answer for this is going to be x equals log 5 divided by 2 log 6 minus log 5. And that's your final answer. All right. I want to just point out like how this is different than what we were doing before, where logs undo exponents and exponents undo logs. You might have had something like this, where e to the x plus 1 equaled just 6. Or even equaled e to the x, or e to the 2x. And because I really only have one exponent here, and actually let's just change this. Sorry about that. Let's make this e to the 2x. Let's make this the exact same problem you had here, except for I am using base e. Notice both my bases are the same. So there's two things I could do. When bases are the same, I know this is true, and I could solve that way. Or if I went back and I said e to the x plus 1 equals 6, how do I undo this? I really only have one base on this, and it's base e. So how do you undo e to a power? You take the natural log. So I would take the natural log of both sides. And on this side, they cancel out. So I get x plus 1 equals natural log of 6. And then I would subtract 1 from both sides. And this would be my exact answer. So that's how they are different. So here you can use the uniqueness property. And here, because I only have one exponent, I can just undo using natural log. Or if it was base 10, I could undo using base 10. All right, that's it for this extra video.